Now let's begin the class. First, I introduce the results of the first examination. Okay. The first examination here, the highest is 85. Okay, 85, and the low rate just 10. Okay, just 10, and the pass. Just 7 students, okay, just 7 students passed the examination. Okay, so far, okay, so far 25, okay, 25 students are failed in the first examination. So the result is 1.5, okay. So now, listen carefully, okay, carefully. I give you another chance, okay. Another chance. The same problem, okay? The same problem. So if you are not satisfied for your result, you can find me the next Tuesday night from 8 p.m. to 10 p.m. Okay? And attend another examination for the same problem, okay? For the same problem. So if you, for example, the first examination you have just 10 marks, okay? So for example, the second you have 17 marks, okay? So I will take the highest, okay? I will take the 17 as your 70 marks as your final result, okay? So if you are not satisfied for your results, so you can find me the next Tuesday, okay? That's Tuesday. And I will introduce the results the next Monday. Okay, next Monday. Today we will introduce the 6.6. Now 200 and 301. Okay, 301. This class we will introduce the 6.6. 6.6 means the fundamental system of calculus. Okay. The fundamental system of calculus. So here, now if I give you a function y equal to fx, and we denote the area under y equal to fx from a to b. We denote the area to type a. Okay. So here a actually is according to the definition of definite integral. We have that a equal to 1. A actually is the net side area, yeah? So the net side area actually is what? Actually is the integral, okay? The definite integral. So what are you doing? Sit down, okay? No, not here, okay? Here is the class, okay? Sit down. Yeah, A, okay. A actually is the definite integral. So here is A actually equal to the definite integral of fx from A to b. Yeah. So now, and we introduce at the antiderivative that here if we choose x between A and B here. Here is x. Here is x. And we denote the area. We denote the area under the curve y equal to fx from A to x. So this area, okay, this area, this part, okay, this part, this area actually is dependent on the right endpoint. Yeah. So dependent is x. So this area we denote it by ax. We denote it by ax. So this area ax actually we denote the area under the curve y equal to fx from A to x. Okay, from A to x. So and we introduce a result. What's the relationship between ax and fx? What's the relationship between ax and fx? Actually, we introduce the result, okay? What's the relationship between ax and the function fx? What's the relationship? Ax what? Yeah, we have the result. The ax, the derivative of ax equal to fx. Yeah?
Yes.
So here we have this result, okay? We have this result, a prime equal to f. And actually here, now it's easy to see that if x equal to a, actually here is this area actually is just a 9, yeah? Just a 9. So actually we have where x equal to a, so capital A equal to what?
0.
Equal to 0, yeah? Equal to 0. And where x equal to b, okay? Where x equal to b, so actually ax is what? Is a, yes? Is a. So here we have a, capital A, b equal to a, yeah? Equal to a. So here we have these three properties. So here now it's easy to see here. A prime equal to fx. So from here we have what? Ax actually is what? It's an antiderivative of f, yeah?
Yes.
So here we have Ax actually equal to the antiderivative of f. The antiderivative of f. So from here we have what? So from here we have a equal to, so from here we can see that the definite integral of f from a to b, this equal to a, this equal to a. So now we know that a equal to ab, yeah?
Yes.
So here this equal to ab. So we know that a equal to 0, yeah? A equal to 0. A equal to 0, so here equal to AB, so here equal to AB minus 0, yeah? So 0 equal to what? 0 equal to capital A, yeah? So here equal to what? Equal to AB minus AA, yeah? So here, now we can see that the definite integral of f from AB equal to capital A B minus capital A, okay? So here, this function, okay? So this function Ax, this function Ax actually is an antiderivative of f, yeah?
Yes.
So here means what? Here means that the definite integral of f from A to B equal to A, capital A B minus capital A, okay? So here this capital A actually is the antiderivative of the integrand, okay? So here we have this result. So actually here, this is A is the antiderivative of f. So now we have a question, if here is another antiderivative of f. So you are it, okay? So if here A, okay, if here capital A is another antiderivative of f. So do we have the same relationship? So here now, for example, now let's see we denote f, capital F, okay? Capital F we denote it by another antiderivative of f. So what's the relationship between capital F and the capital A and the capital A? So now here capital A is an antiderivative of f. Capital F is an antiderivative of f. So what's the relationship between capital A and capital F? Actually, we know that capital F, we can express capital F actually equal to capital A plus a constant, yeah? Yes. Plus a constant. So here equal to what? Equal to capital A plus a constant. Plus a constant. So here now we can see this we can write it in AB. AB we can plus a constant minus a constant. So here actually equal to capital AB plus a constant C minus capital AA plus a constant C. Yes? Yes. So here this one AB, capital AB plus C actually is what? Is capital FB, yeah? So here actually is capital FB. Here AA plus C actually is capital FA, yeah? Yeah. So here equal to FA. So this tells us that the definite integral of f from A to B equal to the antiderivative evaluated at B minus the antiderivative evaluated at A. Okay? Yes. So this is the most important result for the definite integral. Okay? So now we give the result. See page 301, C 6.6.1. Okay? So we have this result, okay? So here, if f is continuous on the closed interval AB, and the capital F is any antiderivative of f on AB, okay? Then we have that. Then we have the definite integral of f from A to B equal to capital B, capital F, B minus capital FA, okay? So this result give me another way to compute the definite integral, okay? Yes. So now actually we have three ways. We have three ways to compute the definite integral. The first way is to use the definition. We have three steps. The first is partition, yeah? Yeah. So the second is the second step is what? Is construct a summation, and the third step actually is to take the limit. Yeah. Yes. So this is the first way. The second way is we need to find the area, find the net set area. We find the net set area to find the definite integral. Yeah. So this is the second way. And this is the third way, okay? This is the third way. The third way is to use this result, okay? And this way is the most used way, okay? This way is the most important way, okay? most important way, of course, I will test it, okay? In the final exam, I will test it, okay? So here,
we can solve in any way.
yes, you anyway, but I think that this is the most easy way, okay?
Yeah, so I think we can choose it.
Yeah, you can choose it, okay?
Because previous two was is a little bit difficult because we need to find area.
Okay. So now I will prove it, okay? I will prove it. So here now, the first we divided, okay? The first we divided the closed interval AB. The closed interval AB into n sub-intervals, and here, so we get some notes, okay? So here is the left endpoint we denoted by x0 and x1 less than x1 less than x2 less than xn minus 1 less than xn actually we denoted by p, okay? We denoted by p by xn, okay? So from here we have what? So from here we got n sub-intervals. The first sub-interval is x0, x1, and the second is x1, x2. So go on, and the last is xn minus 1, xn, okay? xn. So here we got n sub-intervals. So now we denote the y's of each sub-intervals. The first we denoted by delta x1. Delta x1 means the y's of the first sub-interval. So delta x1 equal to x1 minus x0. So and we denoted the y's of the second interval by delta x2 equal to x2 minus x1. So the y's of the last sub-interval we denoted by delta xn, so equal to xn minus 1. Okay. So the second is now we studied the first sub-interval. Okay. For this sub-interval, now we see this function. We know that capital F is anti-derivative, is any anti-derivative of f. So from here we have what? We have capital F, the derivative of capital F equal to what? Equal to fx. Yeah? So here, because capital F is anti-derivative of f. So here tell us that the derivative of f, capital F equal to f. So here tell us that the capital F is definable, yeah? So definable of course continuous, yeah? So here we have what? So from here we have the capital F is continuous on the first sub-interval x0, x1. And definable on the open interval AB, okay? On the open interval AB. So here we can use the mean value theorem, okay? Mean value theorem. Mean value theorem means what? If a function is continuous, on the closed interval and definable on the open interval, then there is at least one point C such that the f prime C equal to what? fb minus fa divided b minus a, yeah? So here b is what? B, so here is the right hand point is x1, the left hand point is x0. So from here by the mean value theorem, okay? By the mean value theorem, we have there there is at least 1 point. This point we denote by x1 star. Okay, x1 star belongs to x0 to x1. To x1, such that we have the capital F prime x1 star equal to what? Equal to capital F x1 minus capital F x0 divided x1 minus x0. Yeah. So here we just use the mean value syllogism. Okay. So now we know here capital F prime equal to what? Equal to F. Yeah. So here actually is what? Here actually is the left here is actually is F prime. No. F x1 star. Yeah. And equal to here is a capital F x1 minus capital F x0 divided x1 x1 minus x0 is what? X1 minus x0 is delta x1, yeah? So here is delta x1. So from here tell us what? Here tell us capital F x1 minus capital F x0 equal to what? Equal to F x1 star times delta x1 times delta x1. So here f x1 star times delta x1. Okay, so we have this result. We have this result. So here, so now we use the mean value syllogism on the first subinterval. We obtain that capital F x1 minus capital F x0 equal to F x1 star times delta x1. Yeah.
Yes.
So now we use the mean value syllogism. Okay. Now we use the mean value syllogism on the second subinterval. On the second subinterval, so we can obtain the same result. Okay, the same result is what? Is F capital F x2 minus capital F x1 equal to what? Equal to F x2 star times delta x2. Yeah. So here is we use the mean value syllogism on the first subinterval. We obtain this result. So here we use the mean value syllogism on the second subinterval. So here we can obtain this result. Okay, this result just the capital F evaluated at the right endpoint minus the capital F evaluated at the left endpoint equal to F x1 star times the width of the subinterval. Yeah. So here now we do it. Here on the second, so on the third, here is capital F evaluated x3 minus capital F x2 equal to what? Equal to F x3 star times delta x3. Okay, times delta x3. So go on. Okay, go on at the last one. Okay. We use the mean value syllogism on the last one subinterval. So we have capital F xn minus capital F xn minus 1 equal to what? Equal to F xn star delta xn. Okay, delta xn. So here we add the left hand side and we add the right hand side. Okay. So here equal to what? So here we add the left hand side. So here we can see here is capital F x1, here is minus capital F x1. So these two cancel. Yeah. Here is capital Fx2 minus capital Fx2. Okay, so these two cancel. Okay, so cancel. Here is also cancel. So here we just have capital Fxn minus capital Fx0. Yeah. So here we have capital Fxn minus capital Fx0. This is equal to what? This is equal to Fx1 star times delta x1 plus Fx2 star times delta x2 plus the last one Fxn star times delta xn. Yeah? So here we write it in summation sum. Okay? Sigma sum, so here equal to the limit of the sigma Fxn star or Fxk star delta xk. Yk runs from 1 to n. Okay? 1 to n. So we have this result. So now we take, here we know xn is what? Xn actually is b, yeah? Xn actually is b, x0 is a, yeah? So here actually is what? Here is actually is equal to fb minus fa, yeah? So the left hand side actually is capital fb minus capital fa, okay? So now we take the limit on both sides, okay? We take the limit on both sides. So we have what? So we have limit max delta xk approaches 0. Here capital fb minus capital fa equal to what? Equal to limit max delta xk approaches 0 summation fxk star times delta xk. Yk runs from 1 to n. Okay. So here now we see the left hand side. Here capital fb minus capital fa. So here this part actually is doesn't matter with delta xk. Yeah. So here this limit actually is a constant. Okay. So here actually this is the left hand side equal to what? Equal to capital FB minus capital FA, yeah? And now we see the right hand side, okay? The right hand side here, xk star and delta xk. Now we know delta xk is what? Is the y's of each subinterval, yeah? And fk star is what? Fk star actually is 1 point belongs to the k subinterval, yeah? So here actually this is what? This is a Riemann sums, yeah? Riemann sums, because we know that f is continuous on AB. F is continuous on AB, so here means what? Here means f is integrable on AB, yeah? So here means f is integrable on AB, so here means what? This limit equal to what? This limit equal to the anti-derived the definite integral of f from AB, okay? So from the left hand side and the right hand side, so we plot the result, okay? So we plot the result. So this is the plot, okay? So of course, if you cannot understand the growth, it doesn't matter, okay?
Yes.
The most important is you must can use the result, okay? Use the result. So now we give remark, okay? We give some remark. So here, FP, capital FP minus capital FA, okay? Actually, we have a rotation, okay? We have a rotation. This rotation means capital F and here is a bracket BA, okay? So here capital Fx bracket here is the up with B, the lower is A, okay? So this notation, okay? This notation means FB minus FA, okay?
Yes.
Minus FA. So capital F is what? Capital F is the antiderivative of F, yeah? So capital F actually is what? Capital F actually is the antiderivative of F, yeah? Capital F is the antiderivative of F. So actually capital F is equal to the indefinite integral of F, yeah?
Yes.
So here actually, here we can rewrite it in this form. Okay, here is B, here is A. So from the left hand side and the right hand side, okay, the left hand side and the right hand side, okay. The left hand side is the definite integral, okay.
Yes.
It's a definite integral, and the right hand side is what? Is the indefinite integral, okay? Indefinite integral. So here this result give a relationship between the definite integral and the indefinite integral, okay? So this result give the relationship between the definite integral and the indefinite integral, okay? So actually here means that the definite integral equal to the indefinite integral evaluated at the upper limit minus the lower limit, okay? So this is the relationship. So here now from here we introduce the definite integral and the indefinite integral. So what's the difference? Here? No. Here, for example, here is fx. Okay, here is the definite integral. Okay, and here is the indefinite integral or antiderivative. Okay, so antiderivative. So what's the difference of these two? The relationship between these two actually is this result. So what's the difference? So here now we can see the indefinite integral actually this, okay? For example, this actually is a function, yeah?
Yes.
It's a function, okay? This is actually the function. For example, here we know x, the antiderivative of x actually is what? Is 1/2 x squared plus c, yeah?
Yes.
So here the antiderivative or the indefinite integral actually is a function, yeah? It's a function. So here this is the function, okay? This is a function or a family of functions because here a plus c, okay? So but here the integral of the definite integral actually is what? This actually is the area, the left side area, yeah?
Yes.
The left side area actually is what? Is a number, yeah?
Yeah, number.
So it's a number.
Yes.
So here actually this is a number, this is a number. So this is the difference, okay? The difference is the definite integral actually is a number. You know the left side area, okay? You know the left side area. And the definite the indefinite integral actually is what? Is a function, okay? It's a function. So this is the difference, okay? This is the difference. So the most important is you can use the result. So now we give many examples, okay? We give many examples. Yeah. So now we first see the three examples. The first example is find the definite integral of 9 minus x squared from 0 to 3. Okay, from 0 to 3. So the second is find the definite integral of cosine x from 0 to 1/2 pi. So the third is find the definite integral of the square root x from 1 to 9. Okay, from 1 to 9. So here now we use the result. Okay. So the first here. So here means that we need to find the antiderivative of 9 minus x squared. Yeah.
Yes.
So the antiderivative of 9 minus x squared. So we use the result actually here equal to what? Equal to here the antiderivative of 9 minus x squared dx evaluate evaluate 3 minus evaluate 0. Yeah.
Yes.
So this step. Okay, this step we use the result. Okay, we use the result here. Okay. So here now we need to find this antiderivative actually equal. This antiderivative actually we know here actually is the antiderivative of 9 minus the antiderivative of x squared dx. Yeah?
Yes.
Here is 3, here is 0. So the antiderivative of 9 is what? Actually 9 you can see as what? 9 times 1, yeah? 1 you can see 9 times x to the 0 power, yeah?
Yes.
So the antiderivative actually is what? Is 9x 0 plus 1 divided by 0 plus 1, yeah?
Yes.
So here this part actually is 9x, yeah? So here actually is 9x, and for this part is what? Minus x 2 plus 1 power divided by 2 plus 1 power, yeah? And here, of course, you need to plus a constant c, okay? Plus a constant c. So, but here actually here is f is any derivative, okay? Any derivative means what? Means you just need to find one antiderivative is okay, okay?
Yes.
We do not need to find all antiderivative. We just need to find one antiderivative, okay? So here this is one antiderivative, yeah? So here is okay. So here is 3, 0. So now we can see here actually is 9x minus 1 by 3 x cubed. Okay. So here is 3, 0. So here equal to what? Equal to 9 times 3 minus 1 by 3 times 3 cubed minus 9 times 0 minus 9 times 0 minus 1 by 3 0 cubed. Yeah. So this part actually is 0. Yeah.
Yes.
So here is 27. Here is 27 minus here is 20. 3 cubed actually is 27. 27 times 1 by 3 is 9. Yeah. So here is 27 minus 9 equal to 18. Okay. So the result actually is 18. So this is the first, okay? This is the first. Now for the second. Okay? Second actually is the same, okay? We use the result, we use the system. So here the definite integral equal to the antiderivative cosine x. Evaluate 1/2 pi minus evaluate at 0. So the antiderivative of cosine is what?
Negative sign.
Is sine, yeah? So here equal to what? Equal to sine x. Here is 1/2 pi 0, yeah? So equal to what? Equal to sine 1/2 pi minus sine 0. Sine 1/2 pi is what? Is 1, yeah? So sine 0 is what? 0, so equal to 1, yeah? So here, now we can see number 3, okay? So now we can see number 3. So, number 3, okay? It's the same, okay? So first is equal to what? Equal to the antiderivative of the square root of x dx. Evaluate 9 minus evaluate 1, yeah? So here, the antiderivative of square root of x actually is what? Is x 1/2 power, yeah? 1/2 power. So here, we find antiderivative is x 1/2 power plus 1 divided by 1/2 power plus 1. Here, 9, 1, yeah?
Yes.
So here equal to x 1/2 plus 1 is 3 by 2 divided by 3 by 2. So here 9, 1, okay? Divided 3 by 2 actually is times 2 by 3. Here is x 3 by 2 power. Here is 9, 1. So here equal to what? So here equal to 2 by 3 times 9 3 by 2 power minus 2 by 3, and here is times 1 3 by 2 power. So now the first is 9, okay? 9 to the power 3 by 2 is what? 9 power 3 by 2, okay? 9 to the power 3 by 2 actually is 9, we can 1/2 plus 1, yeah? So here equal to what? Equal to 9 to the power 1/2 times 9 to the power 1. 9 to the power 1/2 is what?
3.
The square root of that, yeah? So it's 3 times 9, 27, yeah? So this actually is 27. 27 times 2 by 3, okay? So here actually is times 27 minus 1 to the power 3 by 2 is what? 1, yeah?
Yes.
So here is, so actually the result actually is 3, here is 2 times 27, so it's 54 minus 2, so here the result actually is 52 by 3, okay? 52 by 3. So here, now we give some other examples. So here, for example, number 4. Number 4 is the antiderivative of sin x. No. The definite integral of sin x by 5 dx from 0 to 1/2 pi. So this number 5 is the definite integral of secant x squared from 0 to pi by 3, okay? 3x. And number 6 is the definite integral of 5ex from 0 to log 3, okay, dx. And the number 7 is the definite integral of 1 by x dx from minus e to minus 1, okay? And the number 8 is the definite integral of 1 by square root of 1 minus x square from minus 1/2 to 1/2, okay, to 1/2. So here, now we have agreed, okay, we have agreed. That means
Number 6.
Then show about a show.
Nomor klik saya Bapak. Ada nomor klik saya.
Push kora.